Good evening, students. Welcome to the class. Today we will discuss about quadratic equations and its roots, both in real number system and the complex number system, like how the roots come and what are the types of quadratic equations that you can you can do. Like you can find out the equation of the quadratic function by knowing the roots, or sometimes he will give one of the root and he will ask you to find the other root. So we'll see various cases like this. So first, to begin with, let us see the standard form of a quadratic equation. Okay, what is the standard form of a quadratic equation? It is ax square plus bx plus c is equal to 0. And the roots of this equation, what do you mean by the roots of this equation? The roots of this equation is nothing but the values of x, which satisfy the given equation. See, suppose I say like say some x1 is one root of this equation. I say x1 is a root of this given equation. That means when I substitute x1 in the place of x, my equation satisfies the condition given to me. That is, like when I put in x1 in the place of the variable, I get the value of the equation equal to 0. Then I call x1 as my root. So in such a way we find out the roots. Means, like, see here, the power of the equation is 2. That is why it's called as a quadratic equation. So right, when the power is 2, the degree of the expression is 2, then you have 2 roots. Sometimes there may be repeating roots, sometimes there may be different roots, sometimes there are no roots in the real number system. So we'll see those situations when there are roots, when there are no roots. We'll see those situations now. See, now ax square plus bx plus c is equal to 0 is the given quadratic equation, and the roots of this equation are given by this formula. X is minus b plus r minus root of b square minus 4ac by 2a. See, here I am writing two values together, like these are two roots, not one root. A, b, c are nothing but the coefficients of x square, x, and the constant respectively. Right. So if I write this as, say, some alpha is equal to minus b plus root of b square minus 4ac by 2a, and the other root beta, I name it as beta, which is minus b minus root of b square minus 4ac by 2a. Plus or minus is like I take plus one time and minus the other time. So these are the two roots which we have now. These are the roots of this equation. We can derive this also by just using the method of completing squares. You can easily make x as subject from this, and you will end up getting this. Right. So now if these are the two roots, so when can these exist, when can these not exist? Suppose if we are talking about real number system, I'm talking about real number system. Okay. So it is evident, right? We already know that the square roots of negative numbers are not existent, right? So here this b square minus 4ac is called as the discriminant. B square minus 4ac is called as the discriminant because it decides the nature of the roots, like whether the roots are real or not real, or equal roots, and so on. So what are the conditions? Like if you talk about the laws of trichotomy, it's like b square minus 4ac can be equal to 0. Either it should be equal to 0, or b square minus 4ac should be greater than 0, or the other case, the final case, can be less than 0. So the roots will depend upon the nature of this, like whether it is 0, or it is greater than 0, or it is less than 0. It depends upon these three situations, like what type of roots we are going to get. So let us see what will be the situations for each of these cases in the real number system. Suppose I am taking b square my ax square plus bx plus c is equal to 0 is our quadratic equation, right? And the value of x, or I'll say, okay, alpha is equal to minus b plus root of b square minus 4ac by 2a, and beta is minus b minus root of b square minus 4ac by 2a. Now if the first case b square minus 4ac is equal to 0, so what's going to happen? If you look at this carefully, minus b by 2a is the value of alpha. At the same time, beta is also equal to minus b by 2a. That means the two roots are equal. So when b square minus 4ac is equal to 0, you're going to get the values of the roots as equal roots. That is, like when you draw the graph of this quadratic, you get the you get x-axis as a tangent to the parabola. Right, your vertex of that quadratic parabola will be on x-axis. Right, now if b square minus 4ac is greater than 0, then obviously I have alpha is equal to minus b plus some value, say b square minus 4ac's value is some let us say it is k by 2a, and beta will be minus b minus root of k by 2a. These will be two different roots. So alpha and beta are two different roots here we have, which are real numbers. Both of these will be real numbers. They belong to real numbers. We never know whether it is a rational or irrational. If we know that b square minus 4ac is a perfect square, then the roots will be rational roots. Right, when you find out the b square minus 4ac and get it as a perfect square, b square minus 4, the discriminant is a perfect square, then you have the roots as rational roots. And if the b square minus 4ac is not a perfect square, then they are obviously irrational roots, but finally they are real numbers. Right, so you have real roots when b square minus 4ac is greater than 0. So the roots are real and different, like two distinct roots we have. When it is equal to 0, you simply have rational roots, and it's a single root, like it's a equal roots we say generally, repeated roots or equal roots we call them as. So then alpha and beta will be equal. Right, now the final case is b square minus 4ac is less than 0. So if I have b square minus 4ac is less than 0, that is, it's a negative number, right? Then can I find the value of square root of b square minus 4ac? No, right? So there is no root. Then this will be in the set of complex numbers. So b square minus 4ac gets into the set of complex numbers. So here our roots alpha and beta belong to complex numbers. So we have complex roots or imaginary roots, you can say, and these two will be the roots here when your alpha and beta are negative, like I'm sorry, b square minus 4ac is negative, your alpha and beta will be imaginary numbers. So what are these imaginary numbers? Imaginary number is nothing but I is an imaginary number. Right, not only I, there are so many imaginary numbers, but let us talk about the simple imaginary number first now, which is I. I is defined in such a way that I square equals to minus 1. Can we have a number whose square is a negative number in our real numbers? No, right? That's why this is called as an imaginary number. This comes from the imagination, because mathematicians never wanted to give up on anything, right? Mathematicians are like that from the beginning. So when they had to find square roots of negative numbers, they did not find a value for it. So what they have done is, like, they have created a number, imagination. So right, they imagined a number which is I. So 4 can be written as I square times 4, and so I square coming out of the root would be equal to I, and square root of 4, which is 2i, is the square root of negative 4. So whenever your discriminant becomes negative, you can take the help of complex numbers to figure out the roots of that particular equation. I'll tell you how we will find those roots in a while now. Right now, see, you know that the general form is ax square plus bx plus c is equal to 0. This is my general form of the equation, right? What if I am given the roots of the equation? See, I don't know what are the values of a, b and c. I am given alpha is equal to say something like 3, and beta is given as 2, and they ask me to find the equation of the quadratic which has these two as the roots. Then we can find out the relation. You see, to do this we should know the relation between these two roots and the coefficients of the expression, like the coefficient of x square, the coefficient of x, and constant. If you can figure out the relation between them, it is very easily you can use a formula to find out the quadratic equation by simply using these roots. So let us see if there is a relation between the coefficients of the variable and the roots. Now we already know that alpha and beta are equal to they are correspondingly respectively equal to minus b plus root of b square minus 4ac by 2a, and beta is minus b minus root of b square minus 4ac by 2a. And when I add these, I get minus 2b by 2a, which is equal to minus b by a. So the sum of the roots alpha plus beta will be equal to minus b by a. Similarly, when you try to multiply these two, it will be b square minus, so this is in the form of a plus b times a minus b, which will be equal to, if I multiply these two, if I use the multiplication here, it is b square minus of b square minus 4ac, because the root and the square gets cancelled here, and 2a whole square is like 4a square. Right? So when you simplify this, you get c by a, like b square and b square gets cancelled, and 4 you can cancel. So you just get the roots alpha beta, the product of the roots alpha beta as a c by a. These are the sum of the roots and product of the roots of a quadratic equation. So when ax square plus bx plus c is equal to 0 is our quadratic equation, the sum of the two roots alpha plus beta will be equal to minus b by a, and alpha beta is equal to c by a. These are the roots here. The product and sum of the roots here. So let us see how this works when we have imaginary roots, right? Before that, let me tell you the general equation like we discussed, right? Like if we have the sum of the roots and product of the roots, how can we find? Now I want to find this equation ax square plus bx plus c is equal to 0 when I am given the two roots alpha and beta, right? So what do I know? Alpha plus beta is equal to minus b by a, and alpha beta is equal to c by a. So if I can relate this to this, I can easily find out the formula to construct the equation. So I take this ax square plus bx plus c is equal to 0, and I divide this entire thing by minus a. I will say let us simply divide by a, whatever it is. You can divide it minus a or a, nothing is going to make a big difference. So this is going to be x square plus b by ax plus c by a equals to 0, right? Now I want to substitute, because I don't know the values of a and b, but I only know the values of alpha plus beta and alpha beta. Now if you look at this carefully, I can write this as x square minus b by a times x plus c by a equals to 0. So simply you can write x square minus, this would be equal to alpha plus beta times x plus c by a is equal to 0. So I'm sorry, x square minus alpha plus beta times x, yeah, here only would have written like it should be equal to alpha beta. So this is the formula of a general form of a quadratic equation. When you know the roots, like alpha and beta are the two roots which you already know, then you can simply substitute those. For example, like as we discussed earlier, say alpha is equal to 3 and beta is equal to 2 is given. Simply you can say x square minus 3 plus 2 times x plus 3 times 2 is equal to 0. Then x square minus 5x plus 6 is equal to 0 would be the equation of the quadratic that we are looking for, which has the roots 3 and 2, right? So now let us see how we can handle this in our imaginary system. Say suppose now my b square minus 4ac is less than 0, right? Now what are my roots? So alpha is equal to minus b plus root of b square minus 4ac by 2a, and beta is equal to minus b minus root of b square minus 4ac by 2a, right? But we know that b square minus 4ac is a negative number. B square minus 4ac is less than 0. It is a negative number. That means this is imaginary. So we have to write it as something like which can be taken as a positive number. So to make it as a positive number, to find the square root, I take minus common from the alpha. Then this would be equal to 4ac minus b square, right? So by 2a, then alpha will be equal to minus b. When I bring this minus is nothing but minus 1, right? If I can write this as minus 1 as well. So minus 1 is nothing but I square, right? So for you, I'll write one more step, like this becomes I square times 4ac minus b square by 2a. So alpha is equal to minus b. I bring this I square out of the root, then it becomes I root 4ac minus b square by 2a. Right? Then I have a value, another root, beta will be equal to minus b. Same way, if I bring this, I can write this as a root of 4ac minus b square by 2a. Right? Right. Now if we do here alpha plus beta, so when I add this and this, I simply again get minus b by a, because this value here and this value here are positive and negative and they are equal, they get cancelled easily. Right. Now if I am finding alpha beta, so what I have is minus b whole square minus I times I is I square into 4ac minus b square by 2a times 2a is 4a square. Right? Right. Now if we look at this, this is b square minus, see here I square, what is the value of I square? Minus 1 times 4ac minus b square by 4a square. So which will give us b square minus 4ac, so minus of minus is plus here, plus 4ac minus b square by 4a square, which will be equal to c by a even here. So the product of the roots are sum of the roots either in the complex system or in the real number system. The sum of the roots are always equal to minus b by a, and the product of the roots are always equals to c by a. Right? So let us try to find simple solutions of some problems here. So if I want to find the square root of minus I want to find the square root of I. I'm sorry. I'm trying to find the square root of I. So how can we find the square root of I? So I don't know the value of I here. So what I'm trying to do is the square root of I. So I will take this is equal to say some x plus iy. Why I'm taking this x plus iy here is it's a complex number. Yeah, before getting into this, let us say a complex number is of the form always a plus ib. A plus ib, where a is called as the real part and b is called as the imaginary part. Right? A plus ib is a complex number. And one thing you need to remember is when a plus ib is a root of any quadratic. See, generally quadratics have two roots. When you have a plus ib as a root, then its conjugate a minus ib is also a root of that particular quadratic equation. This is a point which you need to keep in your mind when you are solving questions, right? So now I'm taking root I is equal to x plus iy, which is a complex number here for me. So now let us try to expand this like by squaring it on both sides. Then I will get I is equal to x square minus y square. Why I'm getting minus y square? Because it is iy whole square, where I square is minus 1 and y square. and plus 2ixy, right? So if you look at this, like this is a complex number, this is also a complex number, but this has a real part and this has no real part here. So I can write this as 0 plus I. So my real part here is 0. 0 plus I is equal to x square minus y square plus 2ixy, right? Now I can compare these two expressions. My real part is equal to the imaginary part of this equation. So here I get x square minus y square is equal to 0, which gives me x is equal to y, right? And then here when you compare these two, I get xy is equal to 1 by 2, because 2ixy and this one is I, right? So xy is equal to 1 by 2, or you can simply say x is equal to 1 by 2y, right? So you can compare these two now, and you can simply say or else y is equal to also 1 by 2x. You can write any of those, and so x is equal to 1 by 2x. So what you get is x square is equal to 1 by 2, and then we get x is equal to 1 by root 2, then y is also equal to 1 by root 2, and this can be plus or minus, right? So here square root of I would be equal to x plus iy, so plus or minus 1 by root 2 plus or minus 1 by I times 1 by root 2 would be the solution of it would be the root of I, right? Now let us try to find the square root of another complex number, which is root 5 plus 2i. So you can use the same rule, but here we have a real part. We have a real part 5, and this is 2i, right? So let us again use the same thing what we used earlier. You write it as again x plus iy, where x is my real part and y is the imaginary part, right? Now squaring on both sides, you get 5 plus 2i is equal to again x square minus y square plus 2 times ixy, and then x square minus y square equals to 5, and then you have xy here is equal to 1, right? You get xy is equal to 1, which is x is equal to 1 by y, or let us y is equal to 1 by x. Anything is fine, like you can write x is equal to 1 by y, or y is equal to 1 by x. Now I can put this in this one now. So x square minus 1 by x square is equal to 5. So on simplifying this, you get x power 4 minus 1 by x square is equal to 5. Then x power 4 minus 1 is equal to 5x square. So x power 4 minus 5x square minus 1 equals to 0, right? So here you can treat x power x square as say some value, let us say is k. So what do we get? Like k square minus 5k minus 1 equals to 0. Now we will first figure out whether these roots are real or imaginary, right? So what is it? Like b square minus 4ac is what you have to find, and here b is 5. 5 square is 25 minus 4 times 1 times minus 1. Then it's 25 plus 4, which is equal to 29. So there are the roots, but you don't have factors for this, so you can directly go for the formula like alpha is equal to minus b plus root of b square minus 4ac by 2a, which is minus of minus b is minus 5 here, so minus of minus 5 plus root of 25 minus 4ac is we have already found b square minus 4ac. We can directly do it like, okay, plus 4 by 2a. 2a is 2, so it is 5 plus root 29 by plus or minus if you do, and beta will be 5 minus root 29 by 2. These are the two roots, but this is not the complete root yet because this is equal to x square. So alpha is nothing but x square, and this is also x square. So x would be again square root of so x would be equal to square root of 5 plus root 29 by 2 under root. This is plus or minus again, and so this is x1 and x2. X will be plus and x2 will be square root of 5 plus minus 5 plus square root of 29 by 2, and x3 would be plus square root of 5 minus root 29 by 2, and x4 would be minus square root of 5 minus root 29 by 2. These are the four values of the quadratic equation, four roots of this root 5 plus 2i, right? And then finally we are trying to find the roots of a given quadratic equation. So here my given equation is x power 4 minus 4x square plus 8x plus 35 is equal to 0. This is a quadratic equation. It's a quartic equation actually is given to us. He's asking us to find the roots of this, but what is given to us is given 2 plus root of minus 3 is a root of this equation. It's a given root of this equation, right? So what can we write this one as is 2 plus square root of 3i square. Can I do that? Right. So then this can be also written as 2 plus I root 3. So 2 plus I root 3 is one equation, one root given to us for this particular quartic equation. And remember that we discussed earlier, when there is a root, roots always come in conjugate pairs. So if this is a root, then 2 minus I root 3 is also one more root to this particular equation, right? So when I multiply these two, means see, these are the two roots, right? So when I use these two as two roots, and I can construct a quadratic equation, right? Like, which is x square minus of alpha plus beta plus into x plus alpha beta is equal to 0. We can use that, right? So my quadratic here will be x square minus alpha plus beta. When I add these two, I get 2 plus 2 as a 4, right? 4x plus alpha beta. What is alpha beta? When I multiply these two, 2 2s are 4. Okay, let me write it. 2 plus I root 3 times 2 minus I root 3. This will be equal to 0. So I get x square minus 4x plus this is 4 plus 3 is 7. This is a quadratic equation which I have. So with these two as the factors, I can have this as my quadratic. So this is one part. So see, when you are multiplying, see, how will you get a quadratic equation? If you multiply this with another quadratic. So I don't know that. I'm assuming it to be x square, say some plus some kx plus. See here, I know that the last constant term, is 35. So I will know that I know that here I should have a 5, so that 7 5s will be equal to 35, right? So x square minus 4x plus 7 times x square plus kx plus 5 will be equal to 0, or you can simply say this is also equal to x square minus 4x, x power 4 minus 4x square plus 8x plus 35, right? These two are equal. So now when you multiply this, if you compare multiply and compare the terms, maybe see x square and x square will be x power 4. I'm multiplying the constants, right? Now I multiply 4x with this 5 here. Yeah, I'll multiply these two first. 4x into kx is minus 4kx square. I'm taking the terms where I have the unknown value, right? I'm trying to find the x square values now. 4kx square plus 7x square. I'm multiplying these two, and then plus 5x square, right? 5x square. So this value should be equal to the coefficient of x square here, which is equal to minus 4x square. So in other words, I can simply say minus 4k plus 12, if I add these two, should be equal to minus 4. So minus 4k would be equal to minus 16. So k is equal to 4. So I have my value of k here. So what do I get? X square plus 4x plus 5 is equal to 0 is my another expression, right? And now if I have to find the roots of this, it is like you should know what is the discriminant here, like b square minus 4ac. If you do 4 square minus 4 times 1 times 5, which is equal to 0. So I have 4 minus 20, which is 16 minus 20, which is minus 4. So here I have a negative, like my value of this discriminant is less than 0, right? So what will be my roots here? So the equation, let me write the expression again. X square plus 4x plus 5, right? So alpha is equal to minus 4 plus root of, and we got it as minus 4, right? B square minus 4 is, so I'm directly writing it as minus 4 by 2. And beta is equal to minus 4 minus root of minus 4 by 2. So alpha is nothing but minus 4 plus 2i. Root of this is 2i. This is also 2i by 2. And beta is minus 4 minus 2i by 2. Right? So if you can simplify it further, like minus 2 plus I, and beta is equal to minus 2 minus I. So these are the remaining two roots. So what are the four roots we have here? The four roots of the given quadratic equation is 2 plus I root 3, that is given to us. Then 2 minus I root 3 is also a root. And then we have minus 2 plus I and minus 2 minus I. These are the four roots of the given quadratic equation. Right? Well, let us see if you have any doubts. Then we'll try to solve them. Let me see. I see a question asked like ax square plus bx plus c greater than 0 always. Then the discriminant is less than 0. Can you explain? I'm not so sure in what context you guys are asking this, but I can explain it graphically for now, and I'll get back to you once I really understand the question. But let me tell you what it is. See, when you are saying ax square plus bx plus c is always greater than 0, so that means when you are plotting the graph, when you are drawing the graph, you are not touching x-axis. If you say it is equal to 0, if you say ax square plus bx plus c equal to 0, there are places where you are cutting the axis. So it's always greater than 0 is you are always moving away from x-axis. There are no points of contact with x-axis in the real world. In the real world, the graph is always above x-axis in the positive side. You're not getting it down. Like the values of this are always above 0. Means, see, if you take, I'll explain you in more clear way. If you take it as y is equal as a function, if you take it as a quadratic function, ax square plus bx plus c. It's a good question though, but I did not really get the context. But if this helps you, I'm more than happy. Try to understand. If not, please post a comment and I'll again explain it to you in detail. See, I'm treating this as a function, right? I'm treating this as a function, y is equal to x square plus bx plus c. If I say this is equal to 0, I'm saying y is equal to 0. Y is 0. Where y is 0? If my point is on x-axis, right? And if y is not 0, I'm saying y is always greater than 0. That means you are never coming towards the x-axis. You are never touching the x-axis, right? You are always above the, you are hovering above the x-axis, always not touching it. That means what? There is no value of y, no value of x for which y is becoming 0. That means there are no real values of x for which your y value is 0. That means there are no roots for it, no roots in the real life. That is the reason the discriminant you are saying is less than 0. I hope I made sense to you. If you still have a question, you can leave a comment and I will get back to you on this. Let me see if you have any more questions. So I hope you understood the concept today, and in case of this doubt, if you have any further clarifications needed, please just post a comment and I'll be in touch with you. Till then, signing off, your Satish from Toppr. Thank you.